Hi, everybody. This is Mr. Folly, and welcome to Podcast 2.1. We're going to talk about the motion of hot and cold particles. We're going to talk about how more particles equals more heat, because heat is total kinetic energy, which is the energy of motion, and how an alcohol thermometer works. We're going to talk about how we feel temperature. Celsius is based on hot water. Heat is total kinetic energy, and temperature is the average kinetic energy. So let's hop to it. All right, hot and cold motion. So if I have a bunch of particles, and let's say I have four particles, if they're cold, I would indicate them moving with just one little motion thing, okay? And if I colored it in, and just one of them, so we can watch just that one. The colored one does move, but it moves slower. They all move, but just to focus on it, it moves slowly, and it would slowly move. Now, what I probably did that I shouldn't have noticed, the whooshies are on different sides. Now, if it's hot and I had those same four particles, the way I would indicate that is I would put two little whooshies on them. And remember, these things are perfectly happy to bounce off of each other, bounce off of things, and do all kinds of crazy stuff. Now, they won't go so far that they'll leave. So if like this is the top of the container, the top of the water line, it would do that. If it's a gas, it would escape, but more whooshies means faster. So how do you tell if it's hot? Hot means faster, and that equals more whooshies. I hate that word, but it is what they use. Okay. Whoa, that did not do what it's supposed to do. Okay. More particles means more heat. So I think about the energy of something. So imagine if these are like little people standing on the outside of the wall, right? More particles means more heat. So if I've got this particle and it's got one whooshie, this kid right here says, ow. But if I have the same thing set up here and this particle has three whooshies, and it hits this kid right here, this kid goes, oh! And then he becomes, I hope that's the right emoji, knocked unconscious. Okay? So that's if it has more kinetic energy, but that's the average. Okay? So what if I have this one particle, or if I have jillions of these? So there's a saying, death by 1,000 cuts or whatever. But if I have more particles, okay, more particles means more heat. So the way I like to think about this is which will melt more ice cubes. I saw some people with wet hair, so I assume they're making you swim in gym class right now. So the pool is cold. Pool equals cold. Now, it's cold, but it could melt about 10,000 ice cubes. Oh, don't jump around on me here. 10,000 cubes. Because it has lots of whoops, particles with medium energy. Whoops, get back here. But if I had a drop of boiling water, can't melt one. Can't even melt one. There's not enough, right? Not enough particles. So more particles means more heat. So in this, I kind of didn't draw what I wanted to draw here. I drew one of these things. So which one's going to absorb more energy? 4 with 1 or 1 with 3? Let me just keep doing more of these in here. This one has more energy. This one has less energy. Now less, I'm going to call this total. Less energy total, more energy total. And this energy is going to be kinetic energy. And if you remember way back from your Utes, I'll get back here, way back from your Utes, Kinetic energy is the energy of motion. Okay? Okay. Average energy is temperature. So average energy is temperature. So if I have this right here, and these guys, I've got one with 1 and one with 3. The average equals 1 with 2. So that would be the temperature. Okay? Average energy is temperature. Total energy is heat. I use a total energy including mass, because including the mass is really tells you, it's redundant. Total means including mass. Average temperature means what's one particle. So like boiling water, a boiling drop has a very high temperature, very low heat. Okay, but if I had a giant ice sculpture of, say, Aaron, there's a big ice sculpture of Aaron made of ice. It has a low temperature, but a high heat because, whoops, come on, high heat because lots of particles. Okay, so I don't know why this is doing this to me. Alright, so how does a thermometer work? So if this is a cold thing, so this is basically my cheesy thermometer, okay? If this is cold, I either have a few, so they have weak hits. Weak hits, it doesn't push it up very high. But if I have high hits, shoo, the bulb is hit hard, and the bulb is hit hard and moves detector. That's hot. Bulb hit softly and moves just a bit. But I'm going to say smidge because that's such a fun word to say. All right. Go back to that so you can see it. You need to know that Celsius is a dude. Celsius set his scale to be based on water. So, whoops. Whoa, that's a different one. Almost got the one I wanted. Sorry, this is such a moody thing today. So, if you have a scale, you want your 0 to mean something, and you want your 100 to mean something. So Celsius is a dude who said, all right, my 0 is going to be where, oops, let's not do that. 0 is where water freezes. And 100 is where water boils. And then all he did was, okay, well then there's 50. There's 25. By the way, 25 is room temperature. And 37 is body temperature. That's 98.6. Whoops. Okay? Room temperature is about 70 degrees Fahrenheit. And those are pretty much the only Celsius ones you need to be really comfortable with. So remember, temperature is the average motion. Heat is the total motion, including mass. And then know how a thermometer works. And forgive that my tablet was moody. Thank you very much. I hope you have the time of your life. Toodles.